All right, so without further ado, we'll go ahead and get started with today's webinar. So today we're talking about our wireless access points. So we're going to start here with just sort of a general overview on how we group the different categories of access points together. We'll talk about some of the technologies involved that may be unique to Zyxel, and then we'll go through the actual hardware itself. So to begin with, these days, we're splitting up our hardware into two different categories, the flexible category and the ultimate category. So basically any access point where the digits start with a 1 or 2 fall under the flexible category. Any of our access points that start with the number 5 or 6 fall under the ultimate category. So those that are part of flexible, those can be either managed directly or they can be managed with Nebula, our free cloud management solution. And then on the ultimate side of things, in addition to those two options, you also have the ability to use a local area controller for management. So that includes, our USG, ATP series security devices. Those can all also be used to manage access points on top of providing UTM, firewall, VPN type features. In addition, in general, on the Ultimate series, that's where you'll find some of our more advanced technology like dual optimized antennas, smart antennas, our outdoor design products, etc. Not always the case, but that's generally where you're going to find those technologies. So we've got a split up here of one of our access points for you to take a look at. All of our access points essentially are built using the same philosophies here. So one of the things you'll start with by noticing here is that if you look at the housing, there's lots and lots of vent holes to allow heat to escape from inside the housing. Some of our competitors have no vent holes. So when you're dealing with something like an access point, which is solid state technology, heat fatigue over time is one of the leading causes of failure. It can cause the switches inside the microchips themselves to get locked in position. Heat fatigue can also cause solder joints to fail over time. So we have a lot of venting in our enclosures. And you will also notice on most of our APs, we will have a large metal heat sink behind the PCBA designed to draw heat off the PCBA and vent it out of those holes. Next thing you will notice here is when it comes to our capacitors, we only use solid state capacitors. We don't use any form of electrolytic capacitors. Those have a tendency to fail, to dry out, to boil over, etc. So we only use solid state capacitors, and this is true on all of our access points, from our NWA 1123 ACV3, which sells for what, $89, $99, all the way up to our big stuff here. They all follow these same sort of design philosophies. Most of our APs will have a ton of shielding on the PCBA itself. Not only is it designed to help minimize EMI, but it's also designed to filter out interference that may be coming from neighboring 4G or 5G parts of the spectrum. So that is something that can cause interference on access points. So we put additional shielding on there. If you open us up and compare us to most of our competition, you'll find significantly less shielding on the board. The next thing we do is we do not mount our antennas directly to the PCBA like most of our competition. Instead, our antennas are mounted off the board, and there's generally going to be a separate anti-noise spreader that creates isolation between the antennas and the PCBA itself. This acts to help reduce RF interference that might be coming off chips on the board. It also sort of acts as a reflector to help reflect signal that may be coming in from outside back towards the antennas to give it a little bit of boost on the signal gain. So again, this technology and this design philosophy is something you will find across all of our access points, regardless of the price. So now we'll start talking a little bit about some of the technology. So one of the terms you may see when you're looking at our access point data sheets is something called dual optimized antennas. So, or just optimized antenna on some of the newer data sheets. So basically, your typical access point is designed to be mounted on a ceiling, looking down over the area that it's supposed to cover. So because of this, basically the signal is designed to radiate out what's essentially sort of an umbrella shaped pattern. So it's going out in concentric circles and sort of down to cover the area below it. The problem you run into in doing installs is oftentimes you can't, for whatever reason, mount the access points onto the ceiling. So if you take a ceiling mount access point, rotate it 90 degrees to mount it on a wall, you end up with a less than ideal situation when it comes to the antenna patterns. So you end up sending a lot of signal up into the ceiling, down into the floor. If you're in a multi-story building, that may be causing interference between the floors, and you're generally not getting very much coverage out from the wall. So with dual optimized antennas, what we've done is we've spent a little extra money and we've put 2 sets of antennas in for each radio. One antenna that's optimized for ceiling mount, like in a traditional access point, and then another set that's optimized for wall mount. And then you can switch back and forth between those two, either with a hardware switch or with a software switch on the device. So as you're installing these, no problems whether you're mounting it on the ceiling or wall, mount it where you need it to be, go into the software and then let it know if it should be using the ceiling pattern or the wall pattern. Another technology we've got is smart antenna technology. So smart antenna is not something that a lot of different vendors use or provide. The 2 main guys that are using smart antenna are us and Ruckus. So if you've sold Ruckus products in the past or you've had experience with them, you are familiar with sort of the ideas behind smart antenna. So before we get too in-depth onto smart antenna, I want to talk briefly about co-channel interference. So when it comes to using wireless devices, access points, whatever, we've got certain amounts of spectrum that are opened up to us that can be used, right? So, you know, most APs these days will have 2 radios. One radio works on 2.4 gigahertz. The other radio works on 5 gigahertz. So those are blocks of spectrum that are available to us. The problem we run into is when you're using that spectrum is that basically only one device is able to transmit at a time. If you've got multiple devices transmitting at the same time, you run into interference. Now, if you pull up the GUI and just about any access point and look at the 2.4 settings, you will see you have in the United States 11 channels to choose from. The problem is these defined channels are only separated by about 5 megahertz of space, but the channels themselves are actually 20 megahertz in size, and you've got around 60 megahertz total available. So the problem you run into is you can really only have 3 devices operating at a time in the 2.4 spectrum before you start running into interference issues. And remember, 2.4 and 5 gigahertz are shared by more than just Wi-Fi devices, right? Microwaves use 2.4 to cook food. A lot of wireless mice, video game controllers, things like that are operating in the 2.4 or 5 gigahertz spectrum. Basically, anything these days you buy that is wireless in some sort is probably using 2.4 or 5 gigahertz frequencies. So you've got 3 non-overlapping channels here in 2.4, provided you're still using 11B technology. Starting with 11N, one of the ways the increased speed was doubling the amount of bandwidth that an access point is using at a time. So instead of using a 20 megahertz channel, you're now using 40 megahertz channels. So as you can see, you've only got around 60 that's available. So as soon as you add a second device, you are going to have overlap in the bandwidth spectrum being used. So you are starting to run into interference issues. Now, in a typical home, you know, your typical large, you know, 2,500 square foot or bigger, a stick-built house or something with stucco on the outside, it's not going to be that big of an issue. You should generally have enough separation between you and your neighbors that it isn't a problem. However, in condos, hospitality, or offices, you know, you've got a lot more access points crammed into the same area, so you're much more likely to run into these interference issues. Now, 5 gigahertz, on the other hand, opens up a lot more spectrum. So you can see here, if we're using these 20 megahertz channels, you've got somewhere in the neighborhood, I think it's 26 non-overlapping, basically non-interfering channels. The problem you run into here is this middle section. You notice we've got it highlighted in a sort of, you know, peach orange color there. So these are what are called DFS channels. Now, this part of the spectrum was originally used by other legacy licensed RF usage. So when the FCC decided to open this up for everybody to use, you ran into complaints from the people that were already using this as licensed spectrum saying, hey, it's going to cause interference. It's going to degrade what we paid for the right to use. So the FCC came up with this DFS. Basically, your access point, before it can start broadcasting on one of these DFS channels, it has to listen to the channel for a certain period of time, verify that there are no legacy devices using that same channel, and then it can start broadcasting. And if at any time it picks up something that it feels is a legacy device, it then must stop broadcasting and either switch to a non-DFS channel or switch to a different DFS channel. But again, it's got to listen and wait to verify that channel's not being used. So because of that, people that are using DFS channels get more disconnects, and depending on the environment, it may cause more complaints. The other issue you run into with these DFS channels is that a lot of consumer equipment doesn't support DFS. It takes an extra 6 months to get DFS on top of the regular non-DFS FCC certification. So to get product to market sooner, a lot of product ships without that DFS support. And then it can be added later with a software or firmware update, but a lot of consumer products, choose not to do that, or they do make it available, but the end user never upgrades their equipment to be able to support those DFS channels. So because of that, a lot of people choose not to use DFS, right? So as soon as you remove DFS here, instead of 26 channels, you've got 9 non-overlapping channels that you can use. So it's still pretty good, but nowhere near what it was as far as interference goes between multiple access points. And again, the way we bump up speed between different technologies, one of the main ways we've done it is by increasing the amount of bandwidth that each device is using. So if we jump up to 40 megahertz channels, right, we've doubled the speed from 20 megahertz channels that it's available. You've now only got 4 non-overlapping channels. And your 11 AC product, Wave 2 product, can use 160 megahertz channels. So those have to use this DFS spectrum. Or you'll see a lot of businesses will drop it and limit it to 80, specifically because of compatibility issues with consumer equipment. So now you've only got 2 non-overlapping non-DFS channels that you can use. So this becomes really, really important in an office environment, in a conference center or meeting room, someplace where you've got a lot of devices operating in the same area. It can be a lot of laptops and phones connected to the same access point. It can be a lot of access points within reasonable range of each other. And I go more in depth into this in my my Wi-Fi 101 presentation. But anyway, basically, whenever you've got multiple devices broadcasting at the same time on the same channel, you run into what's called co-channel interference. And it's something that's very common, and in most business environments is one of the most common causes of Wi-Fi performance issues. So one of the solutions to this is going to be using smart antenna. Now, traditionally, what you would do is you would reduce the output power on your access points to limit their range so they don't overlap with each other, causing issues, which is absolutely a solution that dramatically reduces the amount of co-channel interference you may experience. Now, it doesn't help you with access points in your neighbors or the office downstairs that you can't manage, but it helps you with those APs that you have direct control over. The downside is, as you're lowering the power of the access point, you're worsening the signal to noise ratio for your client devices. So they may not be able to connect it as fast of speeds as they would if you had your access points operating at full power. So you're sort of trading off signal to noise ratio for co-channel interference. So our smart antenna technology that we use is specifically optimized to be able to increase the number of devices that can use the same access point before you experience any sort of issues with your wireless network. It's designed to reduce interference between access points, increases the range or the amount of area that can be covered, and also has the ability to drop down the amount of power utilization. So again, here's your typical, standard ceiling mount antenna. It's got a nice round pattern. Over here, we've got a wall mount directional antenna, something you would generally use in an outdoor environment. But in both cases, they've essentially got a fixed coverage area that they provide coverage to and where the signal is getting out to. So with smart antenna, we've got this example here. We've got a ceiling mount AP, and we've got a source of interference. In this case, it is a microwave. So it's causing interference and causing performance issues. With smart antenna, instead of having that one fixed ceiling antenna pattern, we have the ability to go through literally hundreds of different antenna patterns and choose the antenna pattern that's best for the environment at that time. And my animation isn't working right today for some reason. So basically, our access point scans the environment and chooses the optimal antenna pattern for each client device, based not only where that device is in relationship to the access point, but also by taking into account other sources of interference and choosing antenna patterns that minimize the antenna's ability to pick up that interference. So with smart antenna technology, it is purely an AP-based technology. It does not require anything special on the client device. It will work with any client devices. And it also works with moving devices, unlike something like beamforming, which really requires very slow motion or no motion on the client side. So just really quick here, we did some performance testing, taking our access point. In this particular scenario, we're comparing it with a Aruba access point. Both access points are 4x4 Wi-Fi 6 technology. And as you can see in our tests here, it makes a significant performance both on the transmitting and on the receiving side of things, as far as the aggregated throughput that the client devices can experience compared to the non-smart antenna technology. So a few years ago, a university group here did their own independent research looking at claims that both Zyxel and Ruckus make about smart antenna. And they decided to put it to the test. So they bought one of our APs, they bought a similar Ruckus AP with their smart antenna technology, and they bought a Cisco access point, no smart antenna, and Aruba, which also does not use smart antenna, and they decided to compare them. So if you look, there's a URL on the bottom there that can take you to where the entire report is, so you can look at all the full details of all the tests they did, how they set up their tests, etc. You can also just Google search Zyxel smart antenna, and you should be able to find one of the first top results there, a link to our own white paper where we've summarized the key parts of their testing. But in general, what they found is that in real world type environments, smart antenna made a huge difference as far as the performance goes, up to 70% better performance. And they even found specifically when dealing with co-channel interference, we dramatically outperformed Ruckus's smart antenna technology as well, which didn't put as much weight on trying to avoid interference issues. So basically with smart antenna, more APs in the same area, more devices on those APs before you start running into performance issues on your wireless network. So now we'll talk a little bit about Wi-Fi 6, which is still a relatively new technology for most of you guys out there. So in theory with Wi-Fi 6, you can have access points that are able to provide 10 gig connections essentially through the wireless network. Now this is going to be similar to any other sort of wireless speed claim when we're talking about the standards. It is based on the combined throughput of not only the data you're sending, but all the additional overhead and protocols that go into account to allow it to work in this unlicensed, very limitedly regulated environment. So realistically, you're going to see speeds probably anywhere from 40 to 50% lower than whatever the data rate is that the device is capable of. It's been designed to provide larger capacity, so more devices on the same network. And this is the first new Wi-Fi technology since 11N that operates on the 2.4 radio. So 11AC devices out there, the 11AC technology is only on the 5 gigahertz radio. With Wi-Fi 6, you now have the ability to upgrade both the 2.4 and the 5 gigahertz radios to Wi-Fi 6. And there are Wi-Fi 6 devices out on the market that don't. So that's something to keep in mind when you're comparing to make sure that Wi-Fi 6 is actually on both radios, not just one of the radios. And we'll talk a little bit about some of the technology here that goes into making this work. You will notice here, though, that with this larger capacity claim, it's some of the same claims that go into, smart antenna. So does Wi-Fi 6 replace smart antenna? And the answer is no. Smart antenna and Wi-Fi 6 are complementary technologies. Both of them are going about increasing the capacity, increasing the density using different technologies. So the overlap with so they don't overlap with each other, they complement each other. So you still get performance gains, pairing smart antenna with Wi-Fi 6 technology. So one of the things they've done here is they've introduced OFDMA with Wi-Fi 6. So traditionally, up until this point, everything has been using OFDM to basically split up the airtime utilization. And it splits things up into essentially 20 megahertz bands. With Wi-Fi 6, you now have, with OFDMA, you now have much greater flexibility in how you are assigning the available airtime, allowing you to better utilize the airtime available and assign it properly to different devices so they don't cause interference with each other. And one thing to keep in mind when it comes to OFDMA, there is both from the access point to the client device and from the client device back to the access point. Not all Wi-Fi 6 access points support it in both directions. Another thing we have here is spatial reuse, the ability to add some extra information onto some packets as they're being sent. That basically allows an access point to listen and say, hey, wait a minute, that signal coming in isn't meant for me, I can ignore it. So it allows you to have more access points closer together, and minimizes some of the disruption and that co-channel interference you would have with non-Wi-Fi 6 devices. And just in general, improvements to how devices determine if they are allowed to broadcast, and some other improvements that are in there basically allow us here, when we're talking about aggregated throughput, that allows aggregated throughput on Wi-Fi 6 devices to remain flat. Whereas as you add more and more wireless clients to that access point versus 11AC and 11N, whereas you add more and more devices, the aggregated throughput actually drops as you increase the number of devices because of how inefficiently they're using the airtime and because of interference issues that's going on. So a huge difference there, again, when it comes to these dense deployments where you've got a lot of devices on the same access point. And again, same story when you've got multiple APs near each other. Again, as you add more and more client devices to those two APs, Wi-Fi 6 aggregated throughput will remain flat, whereas 11N, 11AC, you will see performance aggregated throughput drops as you add more client devices. So as I've already talked about here, not all Wi-Fi 6 devices are built the same. So in the rush to get products out early and claim to be Wi-Fi 6, a lot of vendors used first generation chips that realistically probably should be marketed as pre-Wi-Fi 6. If you're old like me, you remember when 11N came out, there was early stuff that was called pre-N. It had some of the technology of N, but not the full feature set. And we're seeing that same thing here with Wi-Fi 6, only no one's bothering to call it pre-Wi-Fi 6, they're just calling it Wi-Fi 6. So some people are doing that just because the product is older. It came out before the newer, higher generation chips were available that support the full feature set. Some of them are just doing it today as just a means of cutting back on cost to get the prices down. So I've got up there explanations of sort of what's missing between an early generation Qualcomm product and a later generation Qualcomm product. Very similar if we were talking about Broadcom. So you'll see here, as I was mentioning before, you can do OFDMA from the AP to the client, but you can't do clients back to the AP. It's not supported. You can't do upstream MIMO. You don't do TWT. You don't do BSS coloring for the spatial reuse. So you end up missing a lot of features that are really key for differentiating Wi-Fi 6 from Wi-Fi 5 11AC. So it's something to keep in mind, and no one's going to really tell you. You've got to look at the data sheet and see if they mention these technologies both ways. So at the moment, everything that Zyxel is putting out that's Wi-Fi 6 from the NWA 110AX to the WAC 650S is all using later generation chips and support all of the key features that are part of Wi-Fi 6. So when you're buying a Zyxel Wi-Fi 6 AP, you don't need to worry about this. Some of the vendors that are having some of these features missing on them is Netgear's new Wi-Fi 6 products and some Ingenious products. Some of the older Cisco Meraki stuff as well doesn't have the full Wi-Fi 6 feature set. And then as I mentioned before, Wi-Fi 6 can be used on both the 2.4 and the 5 gigahertz radios. But some vendors are only putting it on the 5 gigahertz radio. So for instance, the Ubiquiti U6 Lite only has Wi-Fi 6 on the 5 gigahertz radio. 2.4 is still using Wi-Fi 4. So a 10-year-old technology still on the 2.4 radio. So again, all of our APs on the market, from the NWA 110AX all the way up to the WAC 650S, all of our Zyxel APs have Wi-Fi 6 on both radios. So I want to talk a little bit here about controller-based management, so local area management. So this is where you've got a lot of APs deployed, and you want to use something on your local network to manage those APs. Now, Zyxel offers Nebula, which is our free cloud management platform, but we do know there are those of you out there that either you yourself don't want to rely on a cloud-based solution, or your customers are, paranoid about some of the privacy issues or things like that, even though we've addressed all of those. So for those that are looking to do it, our series, our access points starting with the number 5 or starting with the number 6 can all use a on-premise controller. And it gives you very similar feature set to what you see on our Nebula Cloud platform. The ability for the controller to try to automatically determine the best way to distribute the available channels across the APs to minimize interference. Zero AP configuration. Basically, if you have an active wireless LAN, Zyxel wireless LAN controller on your network, the access point will see that and automatically connect to that controller for providing management. So you don't have to go into the AP and tell it, here's the controller, here's the IP address. It will find it automatically for you. We have our mesh-based technology, so not all APs need an Ethernet connection. Fast roaming technologies. Now, something we have that we don't have in the cloud at the moment is rogue AP detection and isolation. Although I should warn you, here in the US, using isolation may be a FCC violation. So may not be something you want to use here in North America, but with the controller, you can do rogue AP detection where it detects other APs nearby. So you can try to validate and make sure an employee hasn't plugged an AP into an Ethernet connection and put up an unsecured access point, giving people access to the wired network. The ability to do edge-based security, dynamic VLANs, doing AP load balancing, client isolation for guest networks, band steering, all the features that you expect to see in a managed wireless LAN solution, essentially. So here's a list of our products here. As you can see, our VPN series, our USG series, our ATP series, all of these have the ability to manage access points out of the box. And this column here is telling you how many can be managed out of the box. You can see, depending on the model, anywhere from 4 to 8 APs can be managed directly out of the box. And then as you go over here, you can see the maximum number of APs that can be added. So we sell licenses to unlock additional AP management. The license is just for the controller. It isn't for the APs themselves. So it makes it really easy to price out what you want to unlock for what you're doing. So I just want to highlight here a recent third-party review. So this is Network Advisor. And actually, since I put this slide together, they've done a second review where they're specifically, in this case here, comparing our Wi-Fi 6 AP versus the Ubiquiti AP. So you can check that out if you're looking for third-party review and performance testing and things like that. Like I said, he's done another one of our APs just recently as well. So now let's go through some of the different models that we have. So this is starting with our 1X series here. So we've got our NWA 1123 ACV3. This is our entry-level 11AC access point. The V3 launched this year to replace the V2. We have our NWA 1123 ACHD. So this is a Wave 2 MU-MIMO's chipset. Very similar to the 11AC V3. But it gets you an extra Ethernet port and it gets you faster 5 gigahertz performance. You've got one extra spatial stream. So it's around 33% faster than the 11AC V3. And then we've got our NWA 1123 AC Pro. The Pro, just to let you guys know, these are going to be in short supply going forward due to chipset shortages. Unfortunately, we're not getting as many chipsets as we need But this is a older Wave 111 AC product, and it's got 3 spatial streams on both radios. Going up here to our Wi-Fi 6 products, we have the NWA 110AX, our current entry-level Wi-Fi 6 access point, and the NWA 210AX, which is faster. So you get 2 spatial streams on the 5 gigahertz radio on the 110AX. Going up to the 210AX, we get 4 spatial streams. So we've basically doubled the speed between the 110 and the 210 on that 5 gigahertz radio. And also to help support that faster speed, we have a 2.5 gig Ethernet connection on the 210 versus a 1 gig Ethernet connection on the 110. Jumping up here to our 5 and 6 series. So now we're talking about devices which have the ability to be managed by a local area controller. They also include 1 year of our Nebula Pro Pack licensing out of the box. So for those of you using our Nebula cloud management solution, these will include a 1-year license for the extra features that ProPack unlocks for you. So the entry-level model here is the WAC 500. Supply is kind of limited on these. These are also but they are available. And the WAC 500 is also our lowest end AP that supports the secure Wi-Fi functionality that's recently been rolled out in our USG and ATP series. So this essentially allows you to turn the access point into a remotely managed VPN appliance, allowing people to VPN from home back to the office just by connecting to the work SSID on the access point. So if you're looking to do that on the cheap, the WAC 500 is the AP to use. It is a 11AC Wave 2 product. The step up from that here, we have the WAC 6303D-S. So this is our entry-level access point with smart antenna technology. It's faster on the 5 gigahertz radio, about 30% faster than the WAC 500. Gets you that bonus of the smart antenna technology, and it gets you dual Ethernet ports. So you can have Ethernet come in from your switch to the access point, and you can run another Ethernet cable out to an additional device to provide LAN access to. And then we've got our older NWA 5123 AC HD. This will be phased out here probably fairly soon. Nothing official has been announced, but it's probably on its way out. So again, this is a Wave 211 AC product. So basically very similar to the 6303 minus the smart antenna technology. And then we've got our wall plate AP. So these are really popular in hospitality these days. The access points themselves have pass-through ports. So you've got multiple Ethernet ports coming out to connect to other devices in, say, a hotel environment where you'd have Ethernet come in, power the access point with PoE, and then you would have Ethernet coming out to go to things like an IP phone in the room, IPTV distribution, etc. The 5302D-S V2 has smart antenna technology and has more Ethernet ports than the WAC 500H. Both of them have 1 port of PoE pass-through, so you can power a PoE device from them, such as an IP phone in the hotel room. Then jumping up here to our Wi-Fi 6 products, we have the WAC 510D. That's going to be our entry-level 5 series access point. So it's going to be very similar to the 210, the 110, NWA 110AX. So the improvements on this is you get dual optimized antennas, and you get the ability to be controller managed, and you get that 1 year of Nebula Pro Pack bundled with it. The WAC 610D is very similar to the previous NWA 210. But again, you're getting smart antenna, you're getting dual optimized antenna technology, you're getting controller management functionality, and you're getting 1 year Pro Pack licensing bundled with it for the Nebula Cloud. And then our flagship product here is the WAC 650S. So this is our fastest access point, providing 4x4 Wi-Fi 6 on both the 2.4 and the 5 gigahertz radios. It has a third radio that's just there for monitoring, for instance, for DFS channels. So the device, if you get interference on a DFS channel, it already knows which channels it can start broadcasting on. It can also be used for doing rogue AP detection. It has Bluetooth built in. for providing beacon type applications, and it has a 5 gigabit Ethernet connection to help support those faster Wi-Fi 6 speeds that the 4x4 radios are giving you. And then on the outdoor side of things, we've got a couple different models here. We have our WAC 6553D-E. So this is our most heavy duty outdoor access point. It has a heater built in so it can support temperatures down to -40. And it has external antennas that are bought optional. We sell an ANT 2105 antenna that you screw into these, or you can source your own specialty antenna based on what you're trying to do. So you can get directional antennas for one radio or whatever for doing point to point, if you're trying to do backhaul. It's IP66 rated. The next one we have here is the WAC 6552D-S. So this is kind of an interesting one. So this has smart antenna technology built into it. But unlike our indoor APs where the smart antenna technology is able to provide, sort of like a full 360 by 360 coverage area, this is specifically uses the smart antenna technology and narrows it down to a beam that's approximately 90 degrees. So the main usage for these is doing point-to-point links. And unlike your traditional directional antenna outdoor links, with the smart antenna, you don't have to really line it up exactly. So if you're doing it the traditional way, especially if you're using high gain antennas, it's really, really difficult sometimes to get the antennas lined up perfectly between the two locations for that point-to-point connection. So the smart antenna basically simplifies that. So you can just point them roughly in the right direction and the smart antenna will figure out exactly how to send that signal. So it makes deploying point to point a lot easier outdoors. It can also be used for things like, stadiums. So you're providing coverage and you mount multiple of these facing towards where the audience is, and each access point will cover a specific area of the stands where people are sitting. Or you can mount 4 of these on the same pole to provide full 360 coverage, such as in like an RV park. And they will not interfere with each other. They have specifically been designed so you can have 4 of these all mounted together on the same pole without causing interference. Which is really nice. So these are IP67 rated. They do not have the heater built in. And then we've also got this guy here. It's an outdoor enclosure that we sell that you can fit most of our indoor APs into to help mount them outside. So if you need to provide some coverage area at a pool or in an outdoor patio area at a restaurant, you don't need to spend the big bucks for heavy duty. It's in a temperate environment. You can just take one of these enclosures, take one of our indoor APs, mount it inside. And this gives us water protection, gives us a bit of dust protection. It also gives us slightly greater temperature ranges that the APs can be used in before they start running into issues. So it's an affordable option for converting a cheap indoor AP into an outdoor AP. So let's talk a little bit about the competition. So this is just doing a comparison here, our NWA 1123 AC Pro. We've got a couple different vendors on there. The chief competitor to this guy, let's be honest, is the Ubiquiti UAP AC Pro. It's Ubiquiti's best-selling access point. So how do we compete with the UAP AC Pro? Pricing should be very comparable. We have higher output power, 27 dBm versus 22. So you're getting higher signal strength. We support more SSIDs per radio. We can do 8 per radio versus 4 per radio on the Ubiquiti. Ubiquiti has the standard, static ceiling mount antenna. Ours has dual optimized antennas, higher antenna gain, the ability to use SNMP, V2C, and V3. Ubiquiti doesn't offer that. The free cloud management platform, Ubiquiti doesn't offer. The zero config installation, they don't offer that. So it is a very, very compelling, I would say, argument to use our AC Pro versus the Ubiquiti AC Pro. We'll compare here our Wi-Fi 6 products. So we'll take here our 5 series WAC 510D, and we're comparing it to the Aruba AP505 and to the Ingenious. So Ingenious has 2 different models here, an EWS 357 and an ECW 220. It is the exact same hardware. I believe it's just a different software and form factor load. So again, we have dual optimized antennas. The Aruba and Genius just have your traditional static ceiling mount antenna. We have higher output power on both the 2.4 and the 5 gigahertz radio than either HP or Ingenious. One of the key things here I want to talk about, where is it here? Is we've got, our free cloud, but the main thing here I want to talk about is when it comes to the Ingenious is one of those vendors like I was talking about. They're using a very old chip in there that doesn't support the full Wi-Fi 6 feature set. So you're missing out on some very important Wi-Fi 6 features if you use the Ingenious Wi-Fi 6 versus our 510D, which has the full Wi-Fi 6 stack operating in it. And then our last comparison I'll do today, because I know it's kind of dry and boring, the WAC 650S. This is our flagship access point. So it competes with the Cisco 9115, the Meraki MR45, the Aruba 535, and Ruckus's R750. So basically, it's just us and Ruckus that have smart antennas. So if you're doing a high density deployment, us or Ruckus are going to give you a lot better performance than what you're going to experience with Cisco or HP. Higher output power than most of the competitors here on both the 2.4 and the 5 gigahertz radio. All of them are using the 4x4 Wi-Fi 6 technology. Only us and the Meraki have the dedicated monitoring radio, missing from the standard Cisco, missing from the Ruckus there. One of the only models here, at least compared to Cisco here, I guess, with 5 gigahertz or 5 gigabit Ethernet for the backhaul. Cisco and Meraki are both limited to 2.5. So your Ethernet connection is going to become a bottleneck to your Wi-Fi 6 on the Cisco products there. And of course, we offer our free cloud, something none of our competitors are offering. So if you're looking for cloud management, we have the free Zyxel Nebula Cloud. We are doing a webinar specifically on Nebula where we go more in depth into it. The general overview for Nebula, I think, has been rescheduled to October 19th, I believe. We'll send out email announcements for it, though, so you can get invites. So if you want to learn more about our free cloud management solution, attend one of our Nebula webinars. Try is doing one, I believe, next week, specifically talking about the integration of the ATP security appliances into the Nebula Cloud, something which is new. I will also be going through later in October a different Nebula webinar where we talk about some of the changes that are being rolled out currently into Nebula. So that, guys, is today's webinar. Again, send in questions if you have them using the question and answer box. I've also been asked just to highlight for you guys here, our YouTube is called Zyxel America Channel. So there's lots of different Zyxel channels on YouTube. Zyxel America channel is the US channel. And that is where, like today's webinar, for instance, it's being recorded. It will be posted there. So if you missed some of today's webinar, you joined us late, you can log into our YouTube and watch the entire presentation. And that's true for most of our webinars that we do. So you can always go back and watch past ones from previous months. A lot of our webinars, we're redoing them, each month for those of you that missed them, but you can always go to our YouTube channel and find those older ones. And then we are on LinkedIn as Zyxel-US-channel. Yes, I know that's a mouthful. So now on to the questions. Sure. So Craig is asking about listed features of Bluetooth and USB. Can we explain what those two features are for? In general, I would say it's not for common usage. It is for specific specialty applications. In the case of the built-in Bluetooth, that's usually being used as BLE, Bluetooth Low Energy, and the primary application that we see out there is beacons. So you can turn your access point into beacons. In theory, they can push announcements to users. So if you're walking through a store, you walk close to one of these APs, it can, pop up a little advertising message telling you what's going, what there's a sale or what product to take a look at. I believe it's also used on the back end to provide basically tracking of users in an environment. So you use the Bluetooth low energy beacon announcements to sort of track where users are a little bit more granularly than you can do with using Wi-Fi for that. And then the USB is essentially the same thing. The USB just allows you to plug in the dongle. In theory, the USB opens us up to offering other sort of USB options there on a project basis. So, both of those are generally only used for larger specialty deployments where we're integrating in with special software, usually in large retail environments or large hospitality environments. But it is there. So if you're working on one of those types of environments, it is something you can contact us about. We can figure out how to make that work for you. So Rick is asking here, can I give you guys an idea of how older generation Wi-Fi devices operate with Wi-Fi 6? So the short version is Wi-Fi 6 is backwards compatible with all of your older stuff. The trade-off is obviously if you've got older stuff working on there, the access point has to, can't fully take advantage of the Wi-Fi 6 features, right? So you can't take advantage of BSS coloring because these older devices don't support BSS coloring. So you'll lose some of the benefits there, right? So same with like TWT and things like that. So you will see a performance hit on your network versus having a pure Wi-Fi 6 environment, but you still will see performance benefits with Wi-Fi 6 clients connecting to a Wi-Fi 6 access point, even if there are older generation client devices connected to that AP, but you will see a performance hit, but not the full rollback. I probably could have explained that better. Let me know if that didn't answer your question, and I'll try to explain it again. But yeah, it's fully backwards compatible. But yes, to see the absolute maximum performance, it would be great if everything on the network A supported Wi-Fi 6. And then also the other problem you're running into with Wi-Fi 6 is just like some of the APs out there are missing support for some of these key Wi-Fi 6 features. Some of the cheaper Wi-Fi 6 client devices, are trailing behind. So you may have a phone that says it's got Wi-Fi 6, but it doesn't have the full feature set itself. So, and this is something that's, plagued Wi-Fi since the early days, which is, using some of the more advanced features requires a bit of horsepower. And because of that, client devices tend to lag behind. So the access points and your home routers will get the technology first, and then the client devices will slowly trickle in after that with support for all of those features. So, these days, unless you're buying like a dedicated Wi-Fi 6 PCI card for a network run entirely of desktop PCs, or maybe some higher end laptop Wi-Fi 6 cards, you're not going to be getting the full Wi-Fi 6 support. It's not, all those features aren't built into your phones or to your tablets, which may have a lower powered Wi-Fi 6 chipset, but you are getting some benefit over the older. And generally what we're looking at here is, future-proofing yourself. So you go with Wi-Fi 6 today to future-proof yourself for 3 or 4 years down the road when everything is full Wi-Fi 6. You don't have to tear everything out and reinstall it all again. Yeah, so Rick is asking about, the UL and DL, OFDMA and things like that. So when it comes to non-Wi-Fi 6 devices, they won't support OFDMA at all. They'll only be supporting OFDM, the older technology. So again, yeah, to support those older devices, you're going to be going back to 20 megahertz chunks of OFDM channel instead of the OFDMA, which can distribute things in 2 megahertz chunks. So yeah, like I said, there will be drawbacks versus just having a true pure Wi-Fi 6 network with only Wi-Fi 6 clients, but it's not completely negating all of the benefits of Wi-Fi 6. So while I wait to see if there's any more questions or comments, just draw your attention here. We do have user forums, forum.zyxel.com. So this is like most vendors now have these. Unlike a lot of our competition, this forum is actually monitored and used by our team in Taiwan, both R&D and support. So feedback you post there will be seen by people who can make changes. And you will occasionally get them wading in and answering questions that people have rather than just having to rely on your fellow users for answers. It's also where all of our security announcements are first made, where our release notes are first released, et cetera. So for instance, all of our APs have new firmware available currently through Nebula. It has not yet been published for manual upgrades through our FTP site, but the release notes are there on the forum. So if you're wondering what's new after seeing an upgrade announcement that there's firmware available, our forum has those release notes first, so you can see what those changes are and whether you want to make the upgrade or not. Okay, guys, I'm not seeing any more questions. I'm going to go ahead and end today's webinar. If there is something you want to ask, feel free to email me directly, Sean R at Zyxel.com, or reach out to your salesperson, Jacob, Andy, David, and they can relay the question to me as well. So thanks for joining, guys. I really appreciate it.